Bismillahirrahmanirrahim. Assalamualaikum and very good day to you all. In today's video, we are going to talk about bearing life. Okay, this chapter is taken from the chapter 11, Shigley Mechanical Engineering Design book. Okay, and the images here is taken from Google Images itself and the book itself. Okay, so what is a bearing life? Okay, when a ball roller or contact rolling contact stress contact stresses occur at the inner ring, the rolling element, outer ring, because of the curvature of the contacting element. In the axial direction is different than in the radial direction. The equation of body stress are involved in the Hertz equation presented in chapter 3 in this book. Okay, if the bearing is clean and properly lubricated, is mounted, sealed against entrance of dust and dirt, is maintained in well condition, is operated at reasonable temperature, the metal fatigue will be the cause only the cause of failure. Okay, in as much as metal fatigue implies many million of stress applications successfully endured, we need a quantitative life measure. So this statement says that when you buy a bearing and when you use a bearing and the bearing is properly sealed, okay, only the metal fatigue will occur. Okay, because you remember everything, everything has its life expectancy. Okay, you remember in chapter 1, stress strain diagram. Okay, this is the stress over strain diagram. This is the elastic modulus, and all everything we need wood with metal, plastic, life itself. Okay, everything has its life expectancy, and then like this. This is the elastic region. Even the metal, when the time came for the metal, it will come to the yield region, it will come to the fracture, because metal also from ductile eventually it will become brittle because of the temperature, because of the sun, because of the snow, because of the environment and everything. So this is caused by metal failure. uh, so uh, if you can avoid all those dirt or those dust from entering the bearing, only metal failure can happen. However, uh, we do not know when metal failure will happen. Let's say you buy a bearing, you put in your machine, take proper precaution against all the dust, all the environment, all the dirt. You run for the long time. Okay, so you suppose your bearing have a long time. Okay, uh, but because of the metal failure, you do not know when the metal failure will happen. The bearing will damage over time, but it takes a long time. Okay, maybe 2 3 years. Okay, and then this is why bearing life, you take into consideration bearing life, meaning that uh, before the time came, you change the bearing. Okay, before the time came, you change the bearing because you don't know when the bearing will damage. Because that is number one. Number two is the bearing is inside. Probably will be inside your product, so you cannot see with your eye. You must open it, open the casing, then you will see the bearing. Okay, so it is a rare and seldom operation. Okay, so this is why we have to do the bearing life. We predict when the bearing will damage and we replace it accordingly. Okay, common life measures for a bearing are number of revolution of the inner ring or the outer ring. Okay, then this the second one is the evidence of fatigue. The third one is the number of hour used as standard angular bearing speed until the first tangible evidence. Okay, so you can see and in your everyday usage, your table fan, your ceiling fan, okay, your table fan, your ceiling fan, everything is moving, okay. And then when you open up the full speed for the ceiling fan, eventually it will slow down over time because of um, because of the number of hours used. And then you sometimes you may see physically the bearing itself have changed color because of heat affected zone and everything, because of the fatigue failure for the shaft, everything. And then the number of revolution, uh, you see your car have timing belt and everything. You have to change regularly. uh, it says that how many revolution per hours, how many hours, how many revolution speed for the timing belt for your car that you have to change. This is all concerning for the bearing. Is the same concept, meaning that you don't want it to become physically evident that your car is rocking. Okay, you change before it happen. This is the same goes at the bearing. Okay, so you see the graph here, the basic life that we will learn about this in the later slide. Okay, the life expectancy 10%, life expectancy 90% percentile and everything. Okay, this is the bearing life, this is the average life. So we want to avoid bad things to happen to us at this end of life. So before it happened, we change. Okay, before it happened, we change already. Okay, so the term bearing life, commonly used term bearing life is applied to either the or to the measures just mentioned. Important to realize as on fatigue life defined as above is a stochastic variable. Okay, as above distribution associated to statistical parameter. The life measures in the bearing is defined as total number of revolutions of hours at constant speed of bearing operation until the failure criterion is developed. Okay, so this is the total number of revolution. The life of bearing is the total number of its revolution. Okay, stochastic. If you Google image, it will go into the graph like this. This is a stochastic because if you relate uh, you relate the bearing, okay, you relate the bearing with this, especially the bearing inside your car. Okay, your car is moving slow speed, then high speed, then slow speed, then high speed. You do not know. Sometimes you drive 10 kilometer per hour, sometimes you drive 50 kilometer per hour, 100 kilometer per hour. And then this is stochastic, like stochastic graph. Okay, you don't know, especially for the speed that you cannot control. But sometimes the speed is maintained. Okay, like your ceiling fan, the speed is like that. Only three speed, low, medium, and high speed. Only three speed. You already know. This is the term bearing life. Okay. So fatigue failure in bearing. This is from American Bearing Manufacturers Association, ABMA. So the standard apply throughout all over the world, from the American standard. Okay. Under ideal condition, fatigue failure consists of spelling or load carrying surfaces, meaning that if you put overload, okay, suppose that bearing can carry certain number of load, you put overload, uh, it become failure. Okay, it become fatigue failure. And then the spalling, it become overload, then rotational speed, some part of it come out accidentally. This is called spalling. Okay. Uh, ABMA standard states that failure criterion is the first evidence of fatigue. Failure criterion used by Timken Company is this company is mentioned in the textbook. Tinker company, SKF company is mentioned in the textbook. Okay, so they have representative in all over the world. In Malaysia, also have the representative for Tinker company and SKF company. So you can take any company. Okay, this I want to mention this company is mentioned in the textbook. Okay, uh, so it says that spoiling or pitting if on area 0.01 inch square. Timken also observed that the useful life of bearing may extend considerably beyond this point. It is operational definition of fatigue failure in rolling bearing, meaning that although you have exceeded your bearing life usage, suppose it you use for uh, 1 year, you extend for 1.5 year, it also can function. Okay, just that by fatigue failure graph and by wheel boot distribution graph, it is recommended that you change before it shows physical damage. Okay, so you don't want that to happen. The same goes at your car. You don't want your car become damaged. You change something that you have to change, you change. Okay, um, that's why that is the recommendation. Okay, writing life. Writing life is third session by AMBMA used by most manufacturer. Writing life is a group of nominally identical bar defined as the number of revolution and 90% of the group bearing. Meaning that if you remember what you learn in mathematics, you learn in mathematics, okay, that is the bell shape. Okay, graph the bell shape. This is the 10 percentile. Okay, 10%. This is the medium 50%. 50 percentile. This is 90 90 percentile. We will learn about this later on. Okay, in that basically, if you want to play safe, 10 percentile over 10 percentile you change. Okay, if you if you really, if you take uh, you are brave enough, 90 percentile you change, but over 90 percentile definitely you have to change the uh, the bearing, which is very dangerous, go beyond this 90 percentile. Okay, we will learn about this later on. Okay, this is the median life, percentile life in the group of bearing. The term average life is synonym for median life to used as synonym for median life, contributing to confusion. When many group of bearing are tested, median life is between 4 and 10 times, or 4 and 5 times the L10 time. The same goes like this. This is the basic 10 percentile, 50 percentile, 90 percentile. This is the median life. Meaning that, again, I will say, if you are want to play safe, go for 10 percentile. Want to take medium risk, go for 15 percentile, and then you are very take the risk 90 percentile. Beyond this, you must change your bearing. Whatever happen, okay, you must change your bearing. It's very dangerous. Going beyond 90 percentile. Okay, so specific life rating by manufacturers. This is specific life rating by the Ticum company. Again, Ticum company is mentioned in the textbook. Okay, also the SKF company mentioned on in the textbook. Okay, each bearing manufacturer will choose a specific life rating for which low rating is bearing is reported. Most commonly used rating is 10,000 revolution, 10 power of 6 revolution. Okay, typical company is well exception rating is 3,000 hours at 90,000 90,000 revolution. This level of rating is actually quite low for today's bearing, but since the rating life is every reference point, the traditional values have generally been maintained. So meaning that this typical company have been a long time, has been exist for the long time. They set the standard for all other bearing manufacturers. So we just use the standard. Okay, So I think that's all for the video on the uh, on this topic. Okay, so we continue in the next video on bearing load life at rated reliability. Thank you very much.